Friends, this is Professor Ved, and in this video I am going to discuss only three fundamental laws in the world of log. That's it. And I hope that after this you can remember these fundamental laws because they will be very useful when we have to solve log related problems. When we were discussing indices, do you remember? Indices is also a game of power, right? So we were discussing a into x, a into y, and we said that x plus y we could actually write. So what was happening in the world of power? When we were multiplying two numbers, the powers were getting added, right? So when we convert this into log world, we can write like this: log of to the base a of something which is multiplied m into n is equal to log to the base a of m plus log to the base a of n. So power gets added when the number is multiplied on the left side. That is fundamental law 1. Fundamental law 2 is that a raised power x divided by a raised power y. We knew that answer was x minus y. So in the log world, corresponding formula is of something like this. If you get in a log, you can write this as log to the base a of m log n to the base a. And finally the third fundamental law. Do you remember this? A raised power x to the power y. We say that, hey boss, this is nothing than this. So in the world of log, if you ever come up with a situation where m raised power n is given, this you can confidently write by taking n outside and write it like this. That's it. This is what we are going to use to solve many problems in the area of log. Log of m into n to the base a, log am plus log an. Powers get added, powers get subtracted if there is a division, and if there is a power, it gets multiplied, n into log am. That's it. Let's quickly take a few questions and solve the questions to quickly understand how this will be used. Okay then, ready? Let's do that. Okay, question number 1 here is on your screen. Question number 1, it's saying that, hey, log of 1 by 2 what you can write log, simplify this, log of 1 by 2. Oh, not a difficult question, you just have to simplify log of 1 by 2. And remember, if nothing is given base here, no, you can take this as a common logarithm. So if no base is given, then base is assumed as 10, which is the common logarithm. Anyways, so log of 1 by 2, this is a division, right? This we can write log 1 minus log 2. You remember this formula? Which formula it comes from? Log of any base a m by n we can write as log of a m minus log of a n. We remember, from there we got it. Now do you remember what is log of 1? Any idea? Log of 1 is 0. Close your eyes and say, boy, I know this. And answer is minus log 2. So log of 1 by 2 is also minus log 2. Okay. Fantastic. We'll solve one more problem. Okay. The question is going to come on your screen. So 1 by 2 log 10 they have written. Okay, fine. Minus 2 log, I will not write, but you will assume it is 10. plus log 18. Okay, now we have to just solve this thing. Okay, no? We have to solve this thing. Let's see how we can solve. There are a lot of additions. Additions means what? If the powers are getting added, let us say this is minus, but this and this is getting added, no? So we can take them together and we can multiply. If the powers are getting subtracted, we can divide. That is how it is going to happen, right? And if there is something outside this, then if I take inside, it will become a power. So we are going to use everything here. We are going to use log of m by n is log m minus log n. We are going to use log of m into n is log m plus log n, and log of m to the power n is equal to n log m. In fact, what we are going to use is the opposite. We are going to use from this side, because in the answer everything is given in this format. Look at this, what's happening. It's like n log m. So I can convert this in quickly as 25 power 1 by 2. This is log 18, so I'll bring this side log of 18. And 2 log 3 is there, so I can put this as log 3 to the power 2. No problem. We understand that? Absolutely, we understand that. So we have used this one twice, this formula. Okay, and we have not used anything else so far, but we will use now, we will use this one, log m into n. Log m plus log n, it is looking like this, so we will use it. So log 25 1 by 2, root of 25 is 5, that we know. This one remains log 18, fine, and this one becomes log 9. Okay, so now this is plus, so we can multiply, no, 5 into 18. This is minus, so same time we can divide also, no problem. We can do that. Okay, so this one 9, it will cancel and it will become log 10. Now the base is already 10 and number is 10. So any number to the same base is what is the answer? You already know that. 1. This is how we solve it. See, it's very easy, it's very interesting. It's also fun sometimes if you know the formula. Where it's like a puzzle, where to apply which formula. A beautiful question it was. So that was three fundamental laws of logarithm. Two more things, these are observations. Two more things I want you to remember in log. Two more things. Let us discuss what those two things are. Friends, I introduced to you three formula and I asked you to remember that. But here is the main formula. This one is the last. If you remember this and if you know this, any problem in log you will be able to solve. Just remember this. If something is given like this, log a to the root b, you can write this one as log a by log b. That's it. That is it. In the base you could have 10, which is the common thing, or you could have any number in the base. It is all fine. But you can write log of a to the base b as log of a to the base something divided by log of b to the base something. Mostly if you write 10, you are fine when solving problems. If required, you can write a particular base and it will also be okay. Okay, now remember two things here. This formula leads to two interesting things that you should remember, and if you know it, then you can use this trick and you can solve questions even faster. First is that if you spot somewhere something, a multiplication like this, then straight away you write 1. Why? Why? Because log of a to the power to the base b, you can write like this. This one you can write like this, and this cancels. So anywhere you spot something of this kind, this is equal to 1. One more thing, this comes from here. So if you are given log of a to the base b and you only want to write it at the opposite base, you can write it like this: 1 by log of b to the base a. This is from where? This is from here only. The log of AB is equal to 1 by log of B to the base A. Okay. So these are three observations. These are not rules or formula. Three observations. Observation 1. Log of A to the base B can be written as log of A to the 10 divided by log of B to the 10. Log of A to the base 10 divided by log of B to the base 10. This base can be 10 or base could be anything. And from there, we get two very important observations. First, log of A to the base B multiplied by log of B to the base A is 1. AB can be anything. Similarly, log of A to the base B is equal to 1 by log of B to the base A. These are similar things, similar things derived from one particular observation, which is log of A to the base B equal to log of A divided by log of B. When I don't talk about what is the base, it is 10, common algorithm. We will solve a question and you will get my point. Okay? What is the question? Question is this. Hey, gentlemen, prove that. Question is on your screen now. Prove that log of 8 to the base 3 divided by log of 16 to the base 9 multiplied by log of 10 to the base 4. Prove that this is equal to 3 log 10 2. So the good news is that on the right hand side you see log 2 and you also see that the base is 10. So we can work on common algorithm. So when we don't write anything, it is assumed to be, the base is assumed to be 10. So we'll not write anything, we'll save time. Okay, so how can I write this? You tell me. This will be log 8 by log 3. Agree? Okay, fine. And this will be, big thing will be log of 16 by log of 9 multiplied by log of 10 by log of 4. When you do the mathematics, sir, you will find this situation. You will quickly find this situation. Log 9 and log 10 will go up. Oh, log 4, I'm sorry. You will find yourself in this situation. Hey, what's the deal now? We have to break everything, solve everything. How will we solve? Because I've told you. So we have used this trick that we were using in the last slide that I was telling you. Now we will use normal logarithm formulas. What is normal logarithm formulas? We'll try to break everything into the smaller numbers. So because here log 2 we have. So naturally log 8 can be written as 3 log 2. There is no problem. Which means that the rest of it should cancel itself. Let us see whether it does or not. Okay, so what's the deal? The deal is that log 10 to the base 10 is already 1. It's gone out of picture. Now what's the deal? Now the deal is that there is log 9. Log 9 we can write as 3 square, so this will become 2 log 3, and log 4 will become 2 log 2. No problem. Log 3 is already there, so log 3 cancel. Log 16 is 4 log 2, so 4 is cancel and log 2 is also cancel. So there is nothing left actually, everything gets cancelled and we say that this is 3 log to the base 10 2. See, this one was hardly any, difficult. Why? Because everywhere the same thing was there. What was that thing? Log m to the power n, we can write as n log n. This we already know. But what we used here mainly is this formula, which is log of a to the power to the base b is equal to log of a divided by log of b. Alright? Sounds interesting? Sounds interesting. But let's do one more. and then we will enjoy it even, appreciate it even further. One more, please. What is it? Let's see. Okay, so it says that if a is log of 12 to the base 24, b is log of 36 base 24 again, and c is log of 36 base 48, then prove that 1 plus ABC is equal to 2BC. Okay, no issues. We know we'll just take LHS, okay? And we'll say that 1 plus what is ABC? So A is this, and B is this, and C is this. And hey, you know that. How will we write it? We'll write it like this. Log, because this is what we just learned, didn't we? Now everywhere the base is log 10. Now suddenly a lot of things are getting cancelled, aren't they? Awesome. So this is actually looking like this: log of 12 divided by log of 48, which is looking like this: 1 of log 48 is the base and number is 12. Would you agree? Yes. Now 1 can also be written as log of 48 to the base 48 plus log of 12 to the base 48. This both can be written as, if you see, log of 48 into 12. What did we use here? Log m plus n is equal to log m into n. Awesome, awesome, awesome. But what do we have to prove? We have to prove this is 2 into BC. What is B? B is 24, 36. And what is C? 36, 48. Now, the awesome thing you will see is that 2 has to come out. How will 2 come out? Everything I have to show as a power of square. So what is power of square here? Log 48. 48 can be written as 12 into 4 n to 12. Okay, so this can be written as log 48 12 into 2 to the power 2. So this can be written as 2 log 48 here 24. Do you think I can write this as, if I have to change the base now to 36? No. So can I write this as 2 log 24 here 36 into log 36 and here 48? You say how? We can write. How can we write is because log 24 to the base 36 will be log 24 by log 36 multiplied by log 36 by log 48. This we can write. 36 will get cancelled. Log 24 by 48 is equal to log 24 48. It's exactly the same thing here. See this? Now can you see what is this? This is B, my friend. This one, this is C, my friend. We see. Alright. One formula, log A to the base B is equal to log A by log B. One formula, and you see miracles can happen. Of course you have to use other formulas along with that, but this is an awesome formula, right? And remember, with that, log A to the B into log B to the base A, if you multiply that, you will get 1. Or if log A to the base B is given and you want to change the base, then you can say log A to the base B equal to 1 by log B to the base A. That is it. This is the last thing I wanted you to remember. Now you are free to go and solve all the problems in log. Alright? Okay. Fine then.